You don't have to like, again, so the way, let me make sure this stream is going. Okay. Let me share the screen. Let me see. Okay. So let's see, as far as announcements go, this is the top of week 5. So welcome, gentlemen. Okay, so hopefully you were able to access your exam and get that to where you needed to be. I'm under the impression your exam should have been due maybe 3.5 minutes ago, right? So it was available for 7 days. It was due, like I said, 3.5 minutes ago. But even though it was due a few minutes ago, you can actually work on it past the due date. Again, with all of our assignments, we're going to unlimited attempts. The system is set to take your highest score, but any assignment submitted past the due date is a 10% late penalty. So the highest you can earn on any late assignment is 90%. I was sharing with my class earlier that, like what that means is that honestly, if you want an A in my class, it's just sitting there waiting for you to take it. Like it's really just there waiting for you. Like you get unlimited attempts and there's only a 10% late penalty. To me, I'm just like, to me, the only reason anybody doesn't get an A is because they don't want it. And the reason I keep doing this system is because people don't take advantage of it. If everybody was getting an A, then I might make it a little bit harder, but everybody does not get an A. So I was like, okay. So it's not a freebie. I mean, it is a lot of work. I will acknowledge that, but it is what it is. As we move forward, just feel free to unmute yourself if you have questions or concerns about anything. If I do ask you to remind me something towards the end of class, I expect you to remind me. I had a student earlier that wanted to clear something up. I said, hey, just remind me towards the end of class. And we wrapped up class. He was zoned out. I was like, it's okay. Yeah, so I'll check attendance again in another 10 minutes, so about 2:15. Let me see. So exam 1 was due. That was over the first 3 sections, right? So today we're going to be starting section 3.2 over log functions. Let me see if there's anything else. So pretty much a rhythm from here all the way to the end. We have like 3 weeks of lecture, so basically 3 sections, then an exam over those 3 sections. 3 sections, then an exam over those 3 sections, right? So 3 weeks of lecture, 1 week of exam, 3 weeks of lecture, 1 week of exam. And it's pretty much like that all the way to the end, okay? We are rapidly approaching the halfway mark, right? The midterm, the middle of the semester. Yeah, I can't really think of anything else. So I felt like I said what I needed to say. Come on, keep working. Ahead and hop into this section. So I created the lecture for this section, like I think it was yesterday, right? So it's on my YouTube channel. I added to our playlist that we're updating. You may or may not have gotten a chance to watch it. Again, I kind of like, peruse through those videos real quick, and I can see the view count was low. Not that you have to watch it, but it is encouraged that you watch those recordings. I'm not just making them for my health. Watch those recordings, take notes as if you're in class. Now, I mean, obviously you don't have to do it. You're an adult. You decide how you want to work it. I'm just, making a plan. Creating the field for you to play on. Always, it is okay to like just work on the homework and then like read and go back and forth, and that's totally fine too. Let me see if there's anything else. So with this, even though I've made the lecture for this, what I'm going to do is, again, make my way through as many homework questions as I can. And then like as certain ideas and concepts arise from each question, I'll take a moment to try to share some of the backstory as far as the concept for that question, right? So if this is section 3.2 over log functions, 3.1, to kind of go back, was over exponential functions, right? So we explored some concepts there. Like for instance, the general shape of an exponential, it kind of like starts off flat, running along the horizontal asymptote of the x-axis. It passes through the point 0, 1, and then it grows very quickly, right? It grows quickly or exponentially. So then, and then the domain of exponentials is all reals. The range of exponentials is 0 to infinity. So then when we consider logs are the inverse of exponentials, right? So if we think about the graph of the exponential and we think about the diagonal line y equals x, if we took our image and like picked a piece of paper up and rotated the paper about that diagonal y equals x, now we're primed for the discussion on logs. Logs have like a vertical asymptote. They initially start off nearly vertical, running along the right-hand side of the y-axis. They pass through the point 1, 0, and then they veer off to the right. It looks like they flatten out, but they actually don't flatten out. It kind of like, it just gradually keeps increasing. We'll see the graph momentarily. I was just trying to provide a little bit of context. So here we're asked to write the equation in its equivalent log form, right? So this is a exponential equation. So then we can rewrite this as a log. So what we do to rewrite this exponential as a log, we're going to take that base of the exponent, the base being 3, and we're going to swing it to the other side, right? So when we swing the base of 3 to the other side of the equal sign, it now becomes the base of our log, right? So we get the following thing to happen. We'll get log base 3. Let's zoom out so we can see a little bit better. 3 equals 2. Right, it becomes the base of the log. So now we have a log base 3 of 9 equals 2. And so log and exponentials are inverses of each other, right? Okay, so let's go with it. Let's enter. Let's try another one. So we're asked to write in log form. Again, the base of the exponent is 1/5. So we're going to swing it to the right, and it's going to become the base of the log. So we're going to have log base 1/5 of 125. So we're swinging it, we're moving it to the right. It becomes 125 equals -3. If anything is not clear, I'll check attendance in about 5 minutes for the stragglers. And anyway, convert to a log equation. So we take the base of the exponential, which is the capital J, swing it to the right, then it becomes the base of the log. So we're going to have log base J of 34 equals, exponential. So again, we just do our swing. So to go from a log to exponential is essentially the same procedure, right? When we went from exponential to log, we took the base of the exponent, swung it to the right. Go ahead.
Could you go back real quick to the one you
Sure. Sure.
Just wanted to see.
J and a lowercase j exponent.
Okay, yeah, the J's were kind of messing me up. Okay.
It's the same, yeah. Okay. Let's try another one. So we have now to go from exponential to log, we took the base of the exponent, we swung it to the other side, and it became the base of the log. So then to go the reverse, you essentially do the same process. We take the base of the log, we swing it to the other side, and now it becomes the base of the exponent, right? So if we take the base 3, we swing it to the right, we're going to have 3 to the power of 3. 3 cubed. Did your question get answered? No. Yes.
Yeah, it's just a tad confusing because I'm just trying to remember which ones to flip without forgetting.
Because I'm not writing it out. You just hang tight. Like let's try to get to something that's a little bit different, and you'll see me write it out.
Can I do the next one? Let me do the next one. Let me try something.
Yeah. You can have it.
So that's gonna be. Oh Lord.
Okay, so we want to write the log as an exponential, right? So what's the base of the log?
It is 10.
And then so if we swing that base to the other side, now it becomes the base of our exponent. So what's our exponent going to be?
-4.
Be basically 10 to the power of -4.
Right. Okay. Oh, I'm straight then. All right.
Okay. Yeah. If you want to try another one.
Yeah. I'm doing another one. Oh.
Okay. let me walk you through this.
Oh yeah, that's what I don't know about that.
So this one is still the same. It's just that you have to know that natural log, all it is common log base e. So they just wrote it differently, right? So this is the same thing as the common log, and our subscript is e. So this is common log base e. So then if the base is e and we swing it to the other side, so then this is going to be e to the power of 3.1355. Okay, I'll write this one out. Court attendance. What time is it? Attendance after this one.
The one before this, it was e to the power of 3 something, and then what? Okay.
E to the power of that decimal equals 23. We're gonna do another one. These are all gonna be similar. So okay, I need to talk about this one. Let's go here. Let me get a copy. And after I do this, I'll check attendance because I'm pretty sure some people in the waiting room. It should be. Okay. And without a calculator, okay. Let's see. Okay. So it says evaluate without a calculator. Now, the way I usually work these, the first thing I personally like to do, I like to set this equal to y, right? Now, when we have a log function like this, and notice there's no base written, when there's no base written, then for this one there's an implied this is base 10, right? This is the common log, so this is base 10. So now if we use the same technique, if we're gonna, we can evaluate this by, again, just rewriting it as an exponential. So we're gonna use the same technique. We're gonna take the base of the log and swing it to the right, and now it becomes the base of the exponent. So then when we do this, we have 1 over 100 equals 10 to the power of y, all right? So then what we wanna do, we wanna get these two exponents to have the same base, to look as similar as possible, right? So 1 over 100, we can rewrite that as 10 to some power. So 1 over 100 is the same as 10 to what? -2, right? Because 10 squared is 100, and a negative exponent puts it into the denominator. So 1 is the same as 10 to the -2. So then these two exponential expressions are equal to each other if the exponents are equal. So then, long story short, this is true if and only if y equals -2. Okay, let's try another one. Suppose we wanted to check this before we submit it, right? So there's a technique that we have that's called the change of base formula. Actually, we don't need to change the base here because the base is 10. I'll talk about that momentarily when it comes up. Kind of jumping the gun a little bit. But we can still go ahead and check this in the calculator before we submit it. I know it says evaluate without a calculator. We did it without the calculator, but that doesn't mean we can't go back and check it with the calculator, right? So something like this, if we wanted to check in the calculator, we would say what? Log parentheses 1 by 100. Try again. 1 by 100. And it should be -2.
Thank you. I'm gonna go ahead and leave out.
We got -2. We want this one. Okay. You don't have to announce that. Yeah. We got a -2. Next question. Let's try another one. Actually, let me check attendance. Let me hit next. Let me check first. Wow. Okay. Let me do this. Stop the screen share. And let me take attendance. Let's see. That's fine. wait until the 15-minute mark. That makes it so that I'm not having to stop and go so much. Did I get him? This is once you get into my Zoom, if I don't say anything, then that means you've got your attendance credit. So you're good once you gain access. Miss student. Okay. Let me hit save. This class today. Okay, if you're just joining us, so I did the announcement, so I decided to kind of change up the way I take attendance. I take attendance, whenever I get in, like right on the money or whatever. Like if class starts at 2, I take attendance at 2, and I kind of go a little bit back and forth. And then once I've gotten everybody at 2, I'll check again at 2:15, because what I was noticing is people kept trickling in, and then there was too much back and forth, right? For me. So I'll check it again at 2:15, and I might check it again a little bit later, maybe. But usually 2:15 is about that mark that I do the second wave. Okay. Yeah, this one, let's talk about this one, right? Let's write this one down. Here. All this handwritten stuff, you can access a copy of the PDF on our Blackboard page. Okay, and you can also, see the video. I live stream these directly to YouTube. Okay, so evaluate the following expression without a calculator, right? So again, for this one, I'm a fan of. Are you working? In this first, I'll set this equal to y, right? So this one, the base is given, right? And if we're going to evaluate this without a calculator, we're going to rewrite this log as an exponential the same way we did with the earlier examples, okay? So we take the base of the log, which is 9, and we swing it to the other side. And now it's going to become the base of the exponent. So then when we do this, we have the square root of 9 equals 9 to the power of y, okay? So then the next goal is to get these two exponential expressions to look similar. So the one on the left, we want to rewrite it so that basically it's like 9 to some power, right? We already have a 9 to the power of y. Can we get the left-hand side to be 9 to some power? So we can rewrite square root. We can rewrite square root as 9 to the power of 1/2, right? So then at this point, these two exponential expressions are equal. 9 to the half is equal to 9 to the y. This is true if and only if y equals 1/2, right? We got 1/2. And this one we can actually check before we submit, right? So this is the one where we can talk about the change of base formula. So suppose we wanted to, like we're on an exam or something, and we want to do the best we can to make sure that it's correct before we move on, right? We want to try to check our work or confirm our numbers, right? So with something like this, we can actually plug this directly into the calculator. I know the instructions say evaluate without a calculator, but that doesn't mean we can't check with the calculator, right? So what we're going to do, we're going to use this technique called the change of base formula. Notice that the base here is 9, but in the calculator, you have the common log base 10, and you have the natural log, which is common log base e, right? So how do we get to it to be a base 9, right? So we do the following. We're going to say the log of the square root of 9, right? That's just that first part. Now to capture that base 9, we're going to say divided by the log of 9, right? So when you have a base other than 10 or e, to change the base, you just say divided by the log of the base. That's the change of base formula. And if we've done it correctly, we should get an answer of 1/2. Okay. If anything is not clear, or if I need to go back, just stop me. We can go back and look at it and talk about it. Okay, so we got a 1/2. We did it manually, and we confirmed it with the calculator. So we're going to go ahead and submit that. A little trippy, but it's all good. Okay. Write the equation in exponential form and then find the unknown value. Okay. So we're going to solve this one. So we're essentially using the same technique that we've been doing all day. Let's get a copy, and it says do not solve. Let's make sure we have that in there. To include the question ID so that way, like if I'm using it in the future, I know where I got it from, and we have some organization. We almost missed it. Okay. All these handwritten items, you can find it on our Blackboard page. Okay. My tablet's totally kind of like throwing a fit because I do a lot of gaming on my tablet. Mobile Legends, bang, bang. That's the only game I really play on my tablet. And so, I know I've worn it down. It's not as responsive. But it still works. It's still having fun. Okay. These dogs are losing their mind outside. It says write the equation in exponential form, then find the unknown value. Okay. So again, to write this in exponential form, we take the base of the log, we swing it to the side, and it becomes the base of the exponent, right? So then the exponential form is going to be x equals 2 to the power of 3. And then you can quickly get that result, right? Okay, let's go ahead and submit this. So here, that's good. Or with the two swings, we're going to have x equals 2 to the power of 3. Do not solve, okay? And then now if we solve 2 to the power of 3 is 2 times 2 times 2, which gives us 8. Thank you, we are halfway. Thank you.
Wait, I'm sorry, how'd you get the 8 again?
The 8, okay, let's go back.
I looked down for a second.
Yeah. So the first, it basically just had us show our, yeah, you're good, right?
Oh, never mind. I didn't even, I don't know why I didn't think to solve it. Yeah, that makes sense.
It's all good. No worries. Let me see. So okay, let's do this one. Now we're starting to, increase in the complexity a little bit. So let me just say this. I saw this poster when I was a student at Morehouse. It was in the math office in the hallway somewhere. I don't know if it's still there or not, but it said there's no such thing as complex. What we consider to be the complex is just a long string of simple ideas, right? So a lot of times when things seem complicated, it's only because we don't know the basics, right? So not that that's pertaining to anything. It's just these questions are starting to increase in complexity because we're introducing more like terms and variables and things. But again, there is no such thing as complex. What we consider to be complex is just a long string of simple ideas, right? So we just gotta take the time to, go over the basics. And again, math is all about pattern recognition. Write this one. I think I'm gonna try this one without writing. I'll go ahead and put it over. I have a screenshot. I know that first part they want me to on. Just write it in an exponential form. So again, to go from the log form to exponential form, we swing the base. Let me go ahead and submit that result first. of jumping the gun a little bit. So the equivalent exponential form, the base of the log, which is 4, it swings to the right and becomes the base of the exponent. And it says do not simplify. So when we swing that base, we're going to get x minus 1 equals 4 to the power of 3, right? And I went on to do it this way. So now to solve, basically you just go ahead and add 1 to both sides. 4 to the power of 3 is 4 times 4 times 4. So that's 16 times 4, which is what? 40 plus 24 is 64. 64 plus 1 is 65. I just didn't write it out. If I need to write it out, let me know. I feel like if you think about it for like a few minutes, you'll see it, right? But if I do need to write it out, let me know. Okay. Let me definitely write this one out. See, they keep adding more and more, so they're getting quote unquote more and more complex. Okay, I'm totally mesmerized. On my TV, I have like these like beautiful nature scenes from YouTube playing, but there's no audio. I turned the audio off. So it's just these like gorgeous like beaches, like, you know, it just looks so pristine. It looks like a scene out of Moana, to be honest. It's really pretty. And like we're approaching like spring break and everything, and I'm like, yeah, let's get going. Okay, use commas. We don't need that.
Someone said they're in the waiting room.
Okay, let me. I'll tell you in just a moment. Come on. Let's see, who is it? We got a few. Okay. Let's do this. Okay. Let's go like this. Ooh, what do we got? That's fine. Ready? We clicked on it. The stream is still going clearly. I'm gonna switch back over, start the broadcast. Come on. Look at this one. Solve the following equation. So let's do the same thing we've been doing. We've been rewriting the logs as exponentials and then going from there, right? So to do this, we've been taking the base of the log, swinging it to the other side, and using it as the base of the exponent. So then with this one, we'll have the square root. What does it look like? The battery should not be low because it's totally fully charged. Square root of x minus 5 equals 64 to the power of a third, right? 64. What is that, 4 cubed, right? So on the left, square root of x minus 5, 64 is what? 4 to the power of 3. Power to another power, what do we do with those exponents? A power to a power, we multiply those exponents, right? So 1/3 of 3, so they essentially cancel as 1. All right, so we're gonna have 4 to the power of 1, which is just 4. So then we have the square root of x minus 5 equals 4. To get rid of the square root, what do we raise both sides to the power of 2, right? We square it. Because the square root is canceled by the squared, okay? 5 comes down, 4 squared is 16, add 5 to both sides, x equals 21, right? So with this, again, we don't always have that luxury of checking, but whenever possible, you definitely want to check, right? What time is it? solid 10 minutes. They love rubbing up out there. Okay, so say we want to check this before we submit it. We're on an exam. We want to do the best we can to get it correct without having to take the whole exam over, right? So I'm going to use my change of base, and I'm going to do this. I'm going to go to y equals. I'm going to type the log of the square root of x minus 5. Okay. Now to do the change of base, to capture that 64, we're going to say divided by the log of 64. Again, that's a change of base formula. So when there's no base written, the base is base 10. The base of natural log is common log base e. And this one, our example here is the base 64. So to capture that change of base, we divide by the log of the base. Okay. Let's see. That looks good. So then now what I'm going to do, I'm to the right, you see the button that says clear. Left of the clear button is the button that says VARS. I think it stands for variables. I'm going to click on that. I'm going to go to the right to go to Y variables, and I'm going to click on number 1 for function, and number 1 again to call on the function I just typed in, right? So now we're saying let x be 21. So this is like basically plugging it into the function. And then also I'm going to hit math number 1 as a fraction, right? Because I want this to be expressed as a fraction. And if we did it correct, hopefully we get 1/3. Okay. And then we confirmed it in the calculator. It doesn't get much better than that. So yep, let's do this one. Solve the following equation. Let's get a copy. So let's do the same thing that we've been doing, right? We've been rewriting the logs as exponentials. So the base of the log, this guy is going to swing to the right and become the base of our exponent. And this will give us x squared minus 10x plus 28 equals 4, right? 4 to the power of 1, which is just 4, okay? We have a trinomial equation. Sorry. I don't know, it just hit me all of a sudden. I'm getting young in my old age, or old in my young age, one of the two. I totally want to just go to sleep. We got like just under 10 minutes. We're gonna power through. We're gonna go ahead and set this equal to 0 and solve. So we're gonna subtract 4 from both sides. X squared minus 10x gives us what, 24. So plus 24 equals 0. We want to try to, how can we solve this, right? Can you think it's called? Begins with an F. We want to factor, right? So we want to try to factor this trinomial. Can we get it into some form like this? We're looking for two numbers that multiply to give us a positive 24 and add to give us a negative 10, right? Let's say that one more time. We're looking for two numbers that multiply to give us 24 and add to give us a negative 10. So in order for us, when the numbers multiply, in order for them to be positive, they either have to be both positive or both negative. So this plus tells us the signs are the same. This one tells us the larger number is negative, right? So then if you put those together, they both have to be negative. So it should be a negative and a negative. 6 and 4, right? 6 times 4 is 24, 6 plus 4 is 10. So then at this point, we use a technique that's called the zero factor. Basically, it says that when you have two or more things that multiply to give a zero, basically you set each thing to zero and solve, right? If this guy is equal to zero, then everything collapses to zero. If this guy is equal to zero, then everything collapses to zero, right? So if we set each one to zero and solve, we get 4 and 6. Okay. Let's check this. We can check this before we submit it, which is a good habit to build. However you do your homework, that's the same thing that's it's the same way you're gonna behave on the exam, right? So whatever technique you're using to, do your homework, that's the same thing that's gonna come out on the exam. Let's see. Equals. We're going to have the log of x squared minus 10x divided by the log of 4. Okay. Repeated the same process as we did before to do all this. So then now, if we let x be 4, be 1, and if we let x be 6, from 4 and 6, they both work. More. 1, maybe 2. I totally want to reference the explanation I gave earlier. Let me just take a moment. Yeah, because I'm kind of burnt. This piece on the domain of a log, right? Just for a little bit of. So if we consider, and let's do like this, paper. I still don't know why that keeps happening. Okay. They're what, logs? I mean exponentials. Exponentials, they generally they have this general shape. Look like this, right? This is like the point 0, 1, right? So then, and also exponentials. That's my clicks. I think I need to restart it. It's like horizontal asymptote, right? Which is the x-axis. This is without manipulation. So this is like an exponential function. So consider the inverse function of y equals x. Let me see. This is like not. find y equals x right here. And we like basically picked up the paper and rotated about the diagonal y equals x. We're gonna get, I don't think I can do it here digitally. We're gonna get something like this. The blue, the log is in red. And when you take this graph of the exponential and rotate about the diagonal y equals x, you get the red graph. The red graph is the graph of the log function. If we consider the exponential function, I'm watching the clock, exponential function, the domain of an exponential is all rails. In general, without any manipulations. The range goes from 0 to infinity, the open interval, because of the asymptote, right? So that's for exponential functions. Then when we consider the inverse function of log, the domain of the exponential function is actually the range of the log function. And the range of the exponential function is actually the domain of the log function, right? So they essentially like switch places, right? So once you understand exponentials, then it gives you a lot of information about logs. You just got to know how they relate to each other, right? So that's the backstory I wanted to share with that. Let's go ahead and answer this question. So again, the domain of log functions, logs go from 0 to infinity. So you can't take the log of 0 or negative numbers, right? I'm wrapping up, thank you. And then the range of logs is all rails, right? Okay, I just wanted to give that back. So then here, so then the domain, right? Again, we cannot take we can't take the log of 0 or negatives. So in other words, that x minus 1 has to be strictly greater than 0. So then if x minus 1 is strictly greater than 0, add 1 on both sides, x is greater than 1. So then here we're talking about 1 to infinity, right? Infinity always gets a parentheses. And again, we use the parentheses here because we can't take a log of 0. If x were 1, we will get 0. We can't take a log of 0. It's not a function. And that'll be a good place to stop. Okay. Any questions? It is what it is. I do expect you to like process it on your own, work together, look up with the tutors. Hopefully you found the tutors and you're able to connect with them. And again, the real intent of class time is for it to be like Q&A. I just go through the homework just so it's not so much dead air, so you can get like at least what I'm thinking a little bit. But yeah, so if there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Okay, take care, guys. Peace.
See ya.